You're falling. Not slowly. Not like a dream. You're falling at 1,000 miles per hour through clouds the color of amber and rust, and the wind is trying to tear your arms off. The pressure around you is increasing by the second, doubling, tripling, crushing inward from every direction at once. You can't see the ground, because there is no ground. Just deeper, hotter, denser atmosphere stretching thousands of miles below you, and you've been falling for less than 60 seconds. Here's what nobody tells you about Saturn. It doesn't need to do anything dramatic to kill you. It doesn't need a monster or a predator. The planet itself is the trap. Every layer you descend through is worse than the last. The cold becomes heat. The wind becomes a wall. The atmosphere becomes something no material on Earth could survive. Saturn isn't hostile the way a desert is hostile, where you at least stand a chance if you're clever enough. Saturn is hostile the way a star is hostile. It was built to destroy you. So what exactly would happen if you tried? Saturn is the 6th planet from the Sun and the 2nd largest in the solar system. A gas giant roughly 764 times the volume of Earth. But size alone doesn't explain why it's lethal. To understand that, you have to understand what Saturn actually is, because most people have it wrong. Most people picture it as a solid planet with rings around it. Something you could theoretically land on if you had the right equipment. You couldn't. Saturn has no surface. There is no ground. What looks like a planet from space is an impossibly deep ocean of gas and liquid, compressed by its own gravity into something that barely exists as matter the way we understand matter. Getting to Saturn already takes years. NASA's Cassini spacecraft, launched in 1997, took nearly 7 years to arrive. But let's say you're there. Let's say you're at the top of Saturn's atmosphere, suited up, ready to descend. What follows is a death sentence written in physics. The first killer greets you before you've gone a mile. Saturn's upper atmosphere holds winds that reach 1,100 miles per hour. Not gusts, sustained winds. For comparison, the most powerful hurricane ever recorded on Earth peaked at 215 miles per hour, and it destroyed everything in its path. Saturn's permanent jet streams blow at 5 times that speed. They don't fluctuate. They don't calm down. They are the planet's baseline. In 1980, the Voyager 1 spacecraft flew past Saturn and sent back data that shocked scientists. They expected slow, gentle atmospheric movement. What they found were winds that dwarfed anything in our solar system except Neptune. At that speed, no material humans have ever engineered would remain structurally intact. You wouldn't be torn apart dramatically. You'd simply cease to be in one piece. But here's the part that gets me. Even if you survived the wind, the cold finishes you first. At the top of Saturn's atmosphere, the temperature sits around -285 degrees Fahrenheit. That's colder than anywhere on Earth's surface has ever been measured. Cold that causes metal to become brittle. Cold that turns oxygen to liquid. A standard spacesuit offers thermal protection down to roughly -250 degrees Fahrenheit, which sounds close, but isn't. At -285, your suit fails at the seals. At the seams. At every imperfection. Saturn's cold doesn't need to penetrate your suit. It just needs a gap. Now, some of you are thinking, but spacecraft visit Saturn and survive. Fair question. And the answer is they don't descend into it. Every Saturn probe has studied it from orbit or from the upper atmospheric fringe. When Cassini ended its mission in 2017, NASA deliberately plunged it into Saturn's atmosphere to destroy it, because they knew the atmosphere would obliterate it completely within minutes. A spacecraft built to survive the vacuum of space, armored against radiation, traveling for 7 years. And Saturn shredded it in the time it takes to make a cup of coffee. But let's say you've solved the wind and the cold. Let's say you're descending through the cloud layers now, deeper, where the atmosphere thickens. What follows is a pressure problem that has no engineering solution. On Earth, atmospheric pressure at sea level is defined as 1 bar. Humans can survive up to about 3 bars before the body starts compressing dangerously. Joints fail, lungs collapse, nitrogen bubbles form in the blood. At 10 bars, unprotected death comes in seconds. The deeper you go into Saturn, pressure builds at a rate that would make deep-sea diving seem like a relaxing swim. By the time you've descended 60 miles below the cloud tops, you're already at pressures exceeding 100,000 bars. 100,000. The deepest point in Earth's ocean, the Mariana Trench, nearly 7 miles down, sits at roughly 1,086 bars. The deepest submarine ever built can handle around 700 bars before the hull begins to deform. Saturn hits 100,000 bars at 60 miles down, and the planet is 36,000 miles deep. The pressure at Saturn's core is estimated at over 10 million bars. No material that humans have ever synthesized. No titanium alloy, no carbon composite, no ceramic armor. Survives pressures above a few thousand bars without catastrophic failure. You would be compressed into something unrecognizable long before you reach the halfway point. And somewhere below that pressure threshold, Saturn crosses a line that physics makes genuinely strange. Here's the part that sounds like science fiction but is documented science. Deep inside Saturn, hydrogen stops being a gas. Under sufficient pressure, around 3 million bars. Hydrogen molecules are forced so tightly together that the electrons detach from their atoms. What's left isn't quite a solid, isn't quite a liquid, and isn't quite a gas. It's called metallic hydrogen, and it conducts electricity the way metal does. This layer is what generates Saturn's massive magnetic field, 578 times stronger than Earth's. Step into that field. If you somehow reached it, and the electromagnetic forces alone would interfere with every electronic system keeping you alive. Your suit's heating elements, your oxygen regulation, your communications, all of it stops. Scientists at Lawrence Livermore National Laboratory first confirmed metallic hydrogen in lab conditions in 2017, using a laser press that briefly generated 3.7 million atmospheres of pressure. The sample lasted a fraction of a second before the equipment itself couldn't hold. Saturn maintains those conditions across a region thousands of miles wide, permanently, effortlessly. The planet doesn't even notice. Then something changed, or rather, something was found. In 2023, NASA scientists analyzing Cassini's final plunge data discovered that Saturn's atmosphere showed temperature spikes at specific altitudes that no existing model had predicted. The planet was generating heat from within at rates inconsistent with its known age. Saturn releases almost 3 times more energy than it receives from the Sun. We still don't fully understand why. The leading theory involves helium rain. Helium droplets condensing in the upper atmosphere and falling inward, releasing heat as they drop. What that means practically is this. Even the regions of Saturn we thought we understood well enough to survive briefly are warmer and more energetically violent than our models assumed. Every new data point makes Saturn harder, not easier, to account for. The planet is actively stranger than we thought, and stranger, in Saturn's case, means more lethal. Saturn strips something else from you before it kills you physically: time and orientation. A day on Saturn lasts roughly 10 hours and 33 minutes. The planet rotates faster than any other in the solar system except Jupiter. Its axis is tilted 26.7 degrees. Its magnetic poles don't align with its geographic poles. Any descent into Saturn would involve constant disorienting spin, electromagnetic interference disrupting instruments, and no fixed reference point to navigate by. You wouldn't know which way was up. You wouldn't know how deep you were. Your instruments would give conflicting readings in the metallic hydrogen zone. You would make decisions based on bad data, in darkness, while being compressed and cooked simultaneously. Saturn doesn't just kill you. It confuses you first. Here's what we've learned. Survival on Saturn isn't a matter of better technology or more preparation. The obstacles aren't engineering problems waiting to be solved. They are fundamental physics. Wind speeds that exceed anything survivable. Cold that defeats existing suit technology. Pressures no material withstands. An interior that operates by rules that destroy machines built to understand those very rules. Every biological weakness we have. Pressure sensitivity, temperature limits, structural fragility. Saturn exploits completely, simultaneously, without effort. We beat almost every other challenge the solar system has thrown at us through ingenuity and invention. We walked on the moon. We landed robots on Mars. We flew a helicopter on another planet's atmosphere. Every obstacle yielded to enough cleverness. Saturn didn't get that memo. Some places in the universe aren't puzzles to be solved. They're reminders. We are made of Earth, calibrated for one pale blue dot in one quiet corner of one average galaxy. Step outside those parameters far enough, and the universe doesn't accommodate you. It simply continues, indifferent and enormous, doing what it was already doing long before anything alive existed to notice. Saturn has been killing things since before life appeared on Earth. It will keep killing things long after the last human being is gone. It doesn't need to try.